Welcome to 2.6. This is a quadratic forms of quadratic equations and circles. So we have our standard form of the quadratic equation, which is the ax squared plus bx plus c, where a are the coefficients and then x are the variables. I'm not going to go through all this sixth grade stuff. You already know it. So the standard form is in this form. So it's where the squared is in the beginning, the regular, and then the constant, the number, left out number. No one cares about that, right? Okay, and then we're gonna learn new terms today. I don't think it's new, but we're gonna review those terms. So line of symmetry, right, and y-intercept, and vertex as well. But we're not gonna talk about that yet. So the quadratic equation is symmetrical. If you've noticed before, I'm gonna draw a graph right now. Right? Yeah, that's the graph. Okay, and I'm gonna draw a quadratic equation. The quadratic equation is symmetrical. If you notice on my previous videos, it is symmetrical, and that's why there's a name called line of symmetry. Because here's a line of symmetry, right? And these are the 2 points. They're exactly the same distance away from the line of symmetry. 2 points on one y value, exactly the same distance away from the line of symmetry. So we're gonna find the line of symmetry and the y-intercept for the following functions. Now, the y-intercept of the equation is the point where the x is equal to 0. So in this point is where x is equal to 0. We could see that the y-intercept is like around like 0. I say 0.2 or something. 0.2. That's the y-intercept. So if you look at these equations, you can just cross the x squared out, cross the 4x out, and then you'll get the y-intercept. So the y-intercept for the first one is -6. The second one you have to do a little bit more work. So you expand this by FOIL, which I will do it right now, or by distribution. It's the exact same thing, literally. But you go 1, 2, 1, 2, and then x times x is x squared, 3 times x, and x times 3 is 6x, and then 3 times 3 is 9. So 9 is the leftover number, therefore 9 is the y-intercept. Now, third number, there's an 8 right here, so 8 is the y-intercept. It's that simple. You just need to know your 6, your 9, and your 8, and that's the y-intercept of the following functions. Now, the line of symmetry, this is the formula for the line of symmetry, and the line of symmetry is at the point where the vertex is. If you guys are interested, I could try to prove to you that the line of symmetry is this, but it's not important right now because we gotta get through all of the integrated 3 stuff before, so people can actually learn all of the integrated 3 stuff, because there's a lot of stuff in integrated 3 that's algebra based, and people want to learn the algebra and they don't want to actually know the proofs, even though the proofs are quite fun. Anyways, -b over 2a. So this is the b number, right? This is the b number. That's the b number. Well, no, this is the b number. So -15. So first of all, we got -4 over 2, which is 2. -2. So the line of symmetry is not -2. It's x equals -2. Put -2, you will lose 3 to 5 points on your test if you put -2 as an answer to one of your things. So this 6 right here, we'll use that. So -6 over 1, but 2 times 1 is 2. So -6 over 2 is -3. So the answer is x equals -3. Same thing for 3. -15. Gotta be careful. So it's 15, and then this 2a, 2 times 5 is 10. So it's equal to 1.5, or 15 over 10, or 3 over 2. So this is x equals 1.5. So that's the answer. X equals -2, x equals -3, and x equals 1.5. Now we're gonna graph the function. We're gonna graph the function only using. We're gonna graph this function only using these two: the line of symmetry and the y-intercept. Because if you use, we could graph the function using the vertex and all of the fancy stuff, but no, we're not gonna do that. Okay, so from last lesson, if you look at this graph, is it going to be pointing up or pointing down? Is it going to be flat or is it going to be sharp? It's going to be have a vertical stretch or a vertical shrink. Okay, and the answer is it's going to have a vertical shrink and it's going to point up. The cup's going to go up. That sounds a bit weird. Okay, but anyways, we got the line of symmetry, which is negative b over 2a. So negative b over 2a was negative 2 over 2 times this 1/2 right here. So that's 2 times 1/2, which is 1. So negative 2 is 2. 2 over 1 is just 2. 2 is our line of symmetry. X equals 2, not just 2. X equals 2 is our line of symmetry, and our y-intercept is 5, as already given here. So 2 is our line of symmetry. Let's draw that right now. Right, it's going to be an upward pointing. It's going to be an upward pointing graph, and we have our y-intercept as 5, and we want it to be flatter than a regular. So it's probably not going to cross this. It's probably not going to cross this ever. So we're just going to do our best sketch of a graph. And there you go. That's our 1/2 x squared minus 2x plus 5. We can obviously check if it's going to cross this or not, but we're not going to do that. Next, we have intercept form. So the intercept form is in this form xa times x minus p times x minus q, or just x minus whatever number times x minus whatever number, and there's never a plus outside of the and there's never a plus or minus outside of the parentheses. X minus 5, x minus p, x minus q. And we're going to learn a new word that's called vertex, right? And the line of symmetry formula for this is p plus q is over 2. And as I said on the previous in the previous slide, the two points that hit the x-intercept are always equidistant away from the line of symmetry. Therefore, if you want to take the average of the two points that hit the x-intercept, then you will get the point where the line line of symmetry lies in. Therefore, we can solve it. And if you want to figure out the vertex, you can plug the line of symmetry back into the equation. So I'll show you how to do that now. So identify the x-intercept, LOS, and vertex. Right? So the x-intercept for this equation is the x-intercept. The x-intercept for this equation is when this equation becomes 0. So using the zero product property, so anything times 0 is 0. You can plug 4 in, and you can plug -6 in, and it will all be 0. So these are the x-intercept, right? Line of symmetry. Use this formula. -4 plus 6 over 2 is equal to 2 over 2, which is equal to 1. So it's x equals 1. Now, line of symmetry is x equals 1. I don't even know if I have space for graph equation. Anyways, line of symmetry is equal to 1. We're gonna plug it back into the equation. Y is equal to 1 comma minus 4. No, not 1 comma minus 4. 1 minus 4. Just 1 minus 4. 1 plus 6. Okay, there you go. That'll get us -3, 7, which is -21. So our vertex is 1, -21. That's the answer. 1, -21. So we're going to graph this equation. Now we have the x-intercept, LOS, and vertex. We can graph the equation quite easily. Let's graph it. Okay, so we have -3. So that's about right there, right? 7, that's about right there. And then, no, never mind. We have 4, not -3 and 7. We have 4, which is about right there. We have negative 6, which is about right there. Our equation is a positive because, well, x and x. If x and x multiply together, that you get x squared. You don't get negative. So our equation is positive, right? Our line of symmetry is that x equals 1. X equals 1. So we're gonna do that right there, right? And then our vertex is at negative 21. 1, negative 21, which is really down here. Okay, so this is how our equation is going to look like. There you go. Easy. Next, let's do the next one. Our our formula. We're gonna identify the x-intercepts, which is 2 and 8, right? And then we're gonna put our 2 and 8's to use. 2 over 8. 2 plus 8 over 2 is 10 over 2, which is 5, right? So our line of symmetry is x equals 5, right? Put the line of symmetry back in. 5 minus 2, 5 minus 8. We'll get 2, 3, negative 3, which is negative 18. So our vertex is 5, negative 18. Again, a really low vertex. Graph the equation. We already know everything. This time we have a scale factor of 2, so we know it's going to be a little bit more horizontally stretched, a little bit more compressed. No, a little bit more compressed, like the east and west side compressed in. So we're going to do our 5 comma negative 18. First of all, we're going to draw the 5, right? And then the 5 comma negative 18 is right there. And then our two roots are 2 and 8. So we can just do that. That's a really bad parabola. That's actually a terrible parabola. Holy shit, that's a terrible parabola. Whatever. Okay, here's a challenge. If you guys can do it, I'll let you do it. I'm gonna go back to the challenge at the end of the video. Okay, next question. We have the circles now. I think this might have to be split into 2. Okay, so the standard equation of the circle is x squared plus y squared equals r squared. Now I'm going to show you why that's the case. So if you do this is the equation, right? And then this is your circle. Okay, that's a good enough circle, I don't care. And then you have your x. That's your x, right? That's your x. That's your y. And that's your r. So this is, if you can see this, you go, whenever you try to calculate slope, you always go down, then left, then down, then left. And those triangles that you're creating, they're similar. They're always right triangle. So it applies to the same thing. If you want to go from a point to a point in the circle, it's a right triangle. Okay, and our right triangles, we have this special property called the Pythagorean theorem, or most of you know it as a squared plus b squared equals c squared. So what's our a? That's our a. X squared. What's our b? That's our b. Y squared. And what's our c? That's our c. R squared. So that's why we have the equation x squared plus y squared equals r squared. Now the circle equation can be like this, which is the most simple, or it also can be like this, where normally they use k. Okay, kind of messed that up. Normally they use h and k in order to write the equation, but I'm just going to use a and b, right? So a, b is the center. So you can complete the square to find a circle equation. If you want to complete the square, you take half of the middle, and that's how you complete the square. So for example, x squared plus 4x, right? You have this. You have to add 4 to complete the square. But what's the other side going to get? You can't just add 4 out of nowhere. The other side also has to get the 4. Same thing. Y squared plus 8y. What's half of 8? Half of 8 is 4. 4 squared is 16. So you have to add 4, and add 16 to the other side. Now you can complete the square. So you have this number, which is x plus 2 squared, and then you have this number, which is y plus 4 squared, and then 5 plus 4 plus 16 is 25, and that's your circle equation. Don't have to graph it, because I didn't say in the question to graph it, but if you want to graph it, you can. Okay, modeling with mathematics. In exercises 35 and 36, x is the horizontal distance in feet, y is the vertical distance in feet. Find and interpret the coordinates of the vertex. So what's the vertex is what we gotta find, and we gotta know what the vertex represents. So the vertex in this case represents for both questions the highest point that the ball is. That's the vertex, right? So highest point, that's the vertex, what it represents. And then to figure out the vertex, we either use the line of symmetry method, which I'm going to use. I'm going to do 1, so it's negative b over 2a, so negative 1 over negative 0.04, which is 25, right? X equals 25, and then put the 25 back into the equation. You'll get negative 0.02 times 25 squared plus 25 plus 6. 25 squared, 625, multiplied by that, you'll get negative 625 multiplied by 0.02 is 62.5, 6.2, 12.5, there you go, negative 12.5 plus 25 plus 6, which will get you 18.5 feet. That's your distance, the highest point. And for y, for the next one, is negative 1 over 0.02 this time, because it's 0.01x, so x is equal to 50 this time. There's a 50, gonna plug it back in. 50 squared plus 0.7 times 50 plus 6. This side will get you 41. This side will get you 2500. So minus 25 plus 41, you'll get 16 feet. That's your answer. Okay, we're just gonna do one more and then we're done. There's 5 pages, but I'm not ready to do the other ones. Path of a diver is modeled by the function negative x 9x squared plus 9x plus 1, where f(x) the height of the diver in meters above the water and x the horizontal distance from the end of the diving board. What's the height of the diving board? Now the height of the diving board is the height at which the person starts at. And if you look at this graph right here, a person cannot start at a negative time. A person cannot have a negative distance. A person can have a negative displacement, but not a negative distance. Therefore, 1 is our starting path, because when the diver dives, they're going to go higher and then lower. 1 is our starting path because the y-intercept is 1, so at time 0, they're at 1, right? Okay, what's the maximum height of the diver? At the maximum height, we actually have to do the minus b over 2a again. So that's minus 9 over 2 times minus 18, which is 1/2, right? And then we can plug it back in, so negative 9 times 1/2 squared plus 9 times 1/2 plus 1, which will give you negative 2.25 plus 4.5 plus 1, which will give you 3.25. 3.25 meters is the height. It's the maximum height of the diver, which is really fucking tall. It is so tall. That's actually really impressive. That's like that or something. There. And describe when the diver is ascending and when the diver is descending. So the maximum height of the diver is 3.25 meters, right? And then we have 1/2, our 1/2 right here. So the 1/2 is the 1/2 is the horizontal distance. So before the diver has 1/2 of the distance covered. So before the diver has travels 1/2 of a meter, he's ascending. After the diver travels 1/2 of a meter, it's descending, because remember, it's symmetrical. So what goes up must come down. that's basically what we're dealing with. So 1/2 of a meter before this way goes up, and then after 1/2 of a meter is traveled, goes down. Okay, we're gonna go back to the challenge, which isn't really challenging in my opinion, even for people who are bad at math. So the challenge is this. So what are the x-intercepts of this? The x-intercepts of this, 2x minus 3. So the x-intercepts of this is when this is equal to 0. This has to equal 0. Therefore, you add 3 both sides, so you get 2x equals 3, and then x is equal to 3 over 2. That's your first x-intercept. And then your second x-intercept is 3x plus 5 is equal to 0. So 3x is equal to negative 5. X is equal to negative 5 over 3. Negative 5 over 3 is our second x-intercept. So if we want to average these, that's going to be our line of symmetry. 3/2 plus negative 5/3. Okay, you don't have to watch me do basic math, but if you want to, you can. Okay, negative 1/6. That is our line of symmetry. Negative 1/6. So we're going to put x equals negative 1/6 into the equation, which will get us a really, really weird number. I'm just going to do it quick. So negative 1/6 into this equation, you'll get negative 10 over 3 multiplied by negative 1/6 into this equation, I'll get positive 9 over 2. 9 over 2. Multiply them together, you'll get 15. Negative 15, I think. Yeah, negative 15. So y is equal to negative 15. So that is our vertex, negative 1/6, negative 15. So we can plug in our negative 5/3, which is around there, 3/2 around there, right? And then negative 1/6, negative 15, which is all the way down here. And we can make our equation. How cool is that? There you go. It's probably steeper than that. I'm gonna be really honest with you. It's probably steeper than that. But that's gonna be it for today's video. It's a long video because I got a lot of stuff to talk about for this specific thing. Next video will probably be 2.7, and then that's it. That's it for linear and quadratic equations, I think. And then after that, we'll have polynomial equations, which is even more confusing than this. That's gonna be it. If you like it, then press the like button. Suggest me more course in the comments. I haven't been seeing any of those course suggestions. I need more course suggestions, else I'm just gonna keep making these two types of videos, no matter what. So see you next.